Welcome back to College Algebra for Business. Today we're going to be talking about combining functions. We talked about transforming functions in a previous class, but today we're going to combine functions with each other. Let's start by talking about how we will add, subtract, multiply, and divide functions. Let's consider two functions, f of x and g of x. What would it look like if we added these two functions? Sometimes you will see the functions added as just f plus g, but we are going to use this notation. So let's just move this out of the way for a little bit. Now, how do we read that? We would read that as f plus g of x. And what does it mean? Well, it means this. F of x plus g of x. Wouldn't it be easier just to write f of x plus g of x? Well, apparently not if you're a mathematician. If you're a mathematician, the f plus g of x looks simpler. Similarly, f minus g of x means take the function of x and subtract the function of g of x from it. When we multiply and when we divide, here's what happens. And in case all of those colors were becoming a little bit distracting, here are all of those equations in monochrome. Let me reveal why I chose two different colors for those functions in the beginning. That's because I want to define each of these functions now, and I think I will define f of x as x squared plus 2x. And I will define g of x as 3x minus 1. Now that we can actually see the functions that we're going to be working with, let's add them. So f plus g of x is equivalent to, watch, I'm putting in the parentheses again. I like to put in parentheses when I am substituting because sometimes there may be a negative or something else going on that could trip me up if I'm not aware that I'm not just substituting a monomial, I am substituting a binomial. This isn't a very good example of that. Wait till we get to subtraction. Because here, I can just drop those parentheses. They are just a grouping symbol here, and I don't want to group this right now. In fact, I want to add like terms at this point. So I have x squared plus 5x minus 1. F plus g of x gives me x squared plus 5x minus 1. Some of you may be wondering, wait, isn't this just the variable f plus the variable g times the variable x? Well, no. Context is everything. We are talking about functions, and we are using function notation, so we read this as the functions f plus g of x equals, here's what it equals, x squared plus 5x minus 1. Let's do some subtraction. So please remember which functions we are working with. We're working with the functions f, the function f and the function g, and now we're going to do f minus g of x. That means I have x squared plus 2x minus, and I am subtracting the entire function of g, 3x minus 1. Here is an example of where these parentheses come in handy because I have to distribute this negative to each term in the binomial. And now I can just combine like terms. So we need to make a little more room here. So let's just move those up there. But we mustn't forget the functions with which we are working. Let's multiply the functions f and g of x. So in symbols, it looks like this. We're going to multiply f of x, which is x squared, putting it in parentheses, of course, plus 2x, close parenthesis, and now we're going to multiply it by the binomial, which is the function g of x, 3x minus 1. So at this point, we distribute. We're going to get 3x cubed minus x squared plus 6x squared minus 2x. And now we combine like terms. 3x cubed plus 5x squared minus 2x. That is the product of the function f of x and the function g of x. It's time for some division. Let's make some room so we can divide. Here is another way you might see the functions f divided by g of x written. And we would know that that means x squared plus 2x is going to be divided by 3x minus 1. At this point, we're not going to be looking to see if we can combine like terms. We're going to be looking to see if we can simplify our fraction. So let's examine the denominator and the numerator. Oh, there are x's. Can we cancel them? No, because the x's are part of those binomials. Instead, what we need to do at this point is to see if we can factor either the numerator or the denominator. And there is a greatest common factor of x that can come out of the binomial in the numerator, but the denominator cannot be factored. So there really is nothing else we can do to simplify this fraction or to combine like terms. That is our answer. So let's see if we can zoom out and get all of these together. There you go. Here is addition, subtraction, multiplication, and division of the two functions f of x and g of x as defined for this example. Let's do another example. This time, let's look at the function c of x equals 2x minus 1 and the function n of x equals 2x squared plus 5x minus 3. Now I'm pretty sure you can do the addition of these two functions backwards and forwards all day. Let's start by looking at the function n minus c of x. So n of x is 2x squared plus 5x minus 3. But then we are subtracting from that c of x, which is 2x minus 1. And remember, we need to distribute this negative. So that's going to become 2x squared plus 5x minus 3. Our first part of this does not change at all, and I'm not multiplying by anything out here. So I'm just going to go ahead and distribute that negative. I'll get negative 2x plus 1. And at this point, we can combine like terms. So 2x squared plus 3x minus 2. I hope you got all that. I'm going to erase this to bring up our answer and leave some room to do some other calculations. In fact, let's calculate now what we would have if we did c minus n, if we subtracted n from c, the function n from the function c, that is. So we're going to start by writing c of x first. And from that, we are going to subtract n of x, 2x squared plus 5x minus 3. Once again, my first binomial there, my first function, I can just rewrite without the parentheses. But I will have to distribute this negative to each of the terms in the trinomial. And that's going to give me a negative 2x squared minus 5x plus 3. And now I can combine like terms. I get a negative 2x squared, writing them in decreasing order of exponents. 2x minus 5x will give me negative 3x, and negative 1 plus 3 will give me a positive 2. Look at the difference in the answers. With subtraction, order does matter. Now, you should remember that when we are multiplying, the order does not matter in terms of which one we multiply first or put first in order. So I'm going to do the function c times the function n of x. So 2x minus 1 times 2x squared plus 5x minus 3. You could absolutely write the function n of x first and then multiply that by the function c of x. But I'm going to do it this way. So what do I get? I get 2x times 2x squared, or 4x cubed, plus 10x squared minus 6x. Okay, and then I have a minus 1 times 2x squared gives me negative 2x squared. A negative 1 times positive 5x gives me a negative 5x, and a negative 1 times a negative 3 gives me a positive 3. I need a little room. Let's see what this is when we combine like terms. We're going to get 4x cubed plus 8x squared and minus 11x plus 3. I will leave it to you if you wish to do the distribution in this fashion. And when you write your answer in decreasing order of exponents, then you will get the same thing. We know that order does matter when you are doing division, so the function c divided by n of x is not equal to the function n divided by c of x. So let's just leave this for later and work with this first example. All right, so what does this look like? It looks like 2x minus 1 divided by 2x squared plus 5x minus 3. So now, wait a minute, what can we do here? Well, let's see, 2x minus 1, that will not factor. Can we factor the trinomial that is in the denominator? Well, as a matter of fact, yes we can, because I set it up that way. But let's see, 2x squared factors into 2x and x, and then we have a positive 3 and a minus 1 here. Let's check to see if that works. That would give us 2x squared plus 6x minus 1x, which gives us 5x, and then a negative 3. It checks. And would you look at that? Because everything in the numerator is assumed to be in parentheses, the fraction bar there acts as a grouping symbol. I can now go ahead and cancel those. Now when I'm canceling, what I'm really saying is 2x minus 1 goes into the denominator one time. Whoops. And 2x minus 1 goes into the numerator one time. So my final answer is 1 over x plus 3. Let's find the reciprocal. Let's do the function n divided by c of x. Here we have it in its original form. We need to see if we can simplify it. Once again, we're going to factor the function of n of x because we can factor it in the same way, 2x minus 1 times x plus 3. And in the denominator, we have 2x minus 1. Once again, these will cancel. And so in this case, we have 1 left down here. 2x minus 1 divided by 2x minus 1 is 1. 1 up here, and we have x plus 3. So those are two very different outcomes. Actually, are they? No. One is the reciprocal of the other, but they are not the same thing. This is actually the first of 2 videos. We have added, subtracted, multiplied, and divided functions. However, now we need to talk about the composition of functions and putting one function inside of another or taking it out. That will be your second video. Please keep an eye out for it.